First, use a utility knife to scrape away any residue, contaminants, or obstructions that might prevent the lifted land from making full contact with the board surface. If solder masking is close to the repair area, clean it away to allow access for the bonding tip. After removing any contamination and solder mask, re-clean the area using your chemical cleaner and a brush or swab. Then blot dry using a dry wipe. Now let's select a bonding iron tip. Hold different tips over a land next to the one you're repairing until you find the right one. Try to match the tip size to the exact size of the land. If you can't find one the same size, use a tip size that is slightly larger than the land. Never smaller. You must have an even bonding all the way across the surface. The land will not bond at its edges if the tip is smaller than the land. Once the tip has been selected, place it in the bonding iron. The iron comes up to the appropriate temperature for reflowing the film adhesive. Next, we'll cut a piece of adhesive bonding film to fit underneath the lifted portion of the land. The adhesive film is sandwiched between two thin sheets of protective plastic. Peel the plastic out of the way and cut a piece of adhesive from the sheet. When cutting the piece of adhesive, trim it so that it's the same size as the lifted portion of the land. Next, position the adhesive underneath the land. Then place a piece of heat-resistant tape over the lifted land and press the land down into contact with the adhesive film. Leave the tape in place during the bonding process. The heat-resistant tape on top will not melt at reflow curing temperatures. Now we're ready to apply the heat with the hot bonding iron tip and actually bond the land back down to the board. It is important for you to understand that proper bonding procedure involves three things: temperature, time, and pressure. Bonding irons operate at 500 degrees Fahrenheit. Once the iron is placed on the land, the bonding cycle takes 30 seconds. Learning just how much pressure to use will take some practice. There are rules of thumb you can use to get a sense of how much pressure to apply. One of them is to apply the same amount of pressure it would take to turn your thumbnail white if you press down on your thumbnail with your finger. It doesn't feel like much pressure at all, does it? Your instructors may have their own simple rules of thumb to help you get a feel for the correct amount of pressure. Next, gently place the hot bonding tip onto the heat-resistant tape covering the land. Make sure your tip exactly covers the surface of the land while you apply the correct pressure. The heat from the tip passes through the tape and land, causing the adhesive underneath to reflow. Leave the bonding iron in place on top of the land for the full amount of time. The reflow adhesive hardens again or cures, bonding the land to the board. Now remove the hot tip and allow the adhesive to cool. Then slowly and gently remove the tape that was used to cover the land. If some of the adhesive material has oozed out a little bit from the edge, use a small utility knife blade to clean it away. Carefully trim along the edge with the tip of the knife, then gently scrape the excess adhesive out of the way. If dry film adhesive spreads on top of the land during the reflow curing process, later on it can interfere with the formation of a good solder fillet. Finally, clean the area and blot dry. After the land has been rebonded to the board, we'll need to tin the land. This prevents the bare copper from oxidizing in contact with the air. To do this, first place a small amount of solder flux on the land. Next, place the hot tip of your solder iron on the land and melt solder on top of the land. Now you must clean up after tinning. Flux residue that is not properly cleaned away can contaminate and corrode the metal on the board. Manufacturers of solder flux will indicate in their product instructions which type of cleaning solution must be used. Some solders are no clean, in which case very little cleaning is necessary. Simply wiping with an ESD-safe, lint-free dry wipe is sufficient. The final step in this repair process is evaluation. Ask yourself if the land is effectively bonded to the board. It is very easy to see if the land hasn't been well bonded after it has been tinned. The tinning operation will cause the edge of the land to pull up slightly. Check the corners and along the edges of the land. If a proper bond has taken place, the land will have a firm bond along the edge. Finally, check to see that the land is in alignment with others and that the spacing between the land and its neighbors is correct. Spacing requirements on the board cannot be violated. We're ready now to learn how to replace an isolated surface mount land. This repair involves replacing a damaged or missing land using replacement lands that are coated with an adhesive back. They are available in many sizes and shapes and come ready to use on frames. They can be trimmed and customized if a special size or shape is needed. These replacement lands typically have 4 layers. On top, the land is often solder coated or pre-tinned. Just under the solder coating is the actual land itself. It is made of copper foil. Underneath the copper is a layer of brown oxide material. This is a layer of material that enables the bonding or adhesive agent to make a mechanical bond with the copper. On the very bottom, below the brown oxide, is the dry adhesive bonding material. Again, the first step in this repair process is analysis. Start by looking for laminate damage. If there is board damage, repair it first. Now we'll look at the land itself. Is the land there? If it is, decide if it can be rebonded. If the land is not there, or if it is heavily damaged, continue with this repair procedure and replace it with another land from a frame. Let's begin the actual work of the process. First, let's clean the area of the missing land thoroughly. Remove any residue, contamination, or masking material from the repair site. Then clean the area once again. To select a replacement land from a frame, move the frame over the lands that are next to the one you are replacing. Find one that has the same electrical characteristics as the original. It must be the same size and thickness. If you can't find a size match, ask a supervisor to come over and help you decide which land to use. Once you've selected a replacement land, choose the bonding iron tip by placing them over the land in the frame. Find one that is the same size or just a bit larger. After the tip has been chosen, place it in the iron and let it start to heat. Next, if the land has to be made smaller, trim it while the land is still attached to the frame. Most lands are extremely small, and the frame gives you something to hold on to. Now let's cut the land out of the frame. You may have to do some additional trimming when the land is free of the frame. It's helpful to have a method to move and position the land. This can be done with a piece of heat-resistant tape. Stick it down to the top of the land. Now we can use the heat-resistant tape as a handle to maneuver the land into position. Remember that the land must be in precise alignment with the other lands in its neighborhood. When the land is properly aligned, secure it to the board with the heat-resistant tape. The tape holds the land in place for bonding. The use of heat-resistant tape to position, align, and hold the land isn't always possible if the board is populated with a lot of other components clustered around the repair site. In this instance, you can use your tweezers to carry and position the replacement. The second part of this positioning and aligning technique is to hold or tack the land temporarily in place. Take a pointed bonding iron tip and heat it up. Hold it to one corner of the land for no more than 10 seconds. This starts to reflow the epoxy bonding agent on the bottom of the land, just enough so that the land will stay in place. Now we're ready to bond the replacement. Position the hot tip directly on the land and bond the land to the board using the correct combination of temperature, pressure, and time. After the curing cycle has been completed, lift the iron tip and allow the bonding agent to cool. Then remove the tape if you used it and carefully clean the area. Remember to tin the land if it's not coated with solder already, and replace the solder mask if it's necessary for cosmetic purposes. The last step is evaluation. Make sure that the land is thoroughly bonded and check for alignment and proper spacing. The next process uses a liquid epoxy to rebond a lifted conductor. Step 1 of the process is to analyze the damage. Look for any laminate damage first. Then look at the conductor. Can it be reused? When making that decision, you have to check that the conductor has not been stretched, crunched, or damaged in a way that would make it unusable. Let's assume you decide to reuse the original conductor. We'll begin the work section with a good cleaning. Clean the area around the damage and remove any obstructions that would prevent the circuit from making contact with the laminate surface. Then clean the area of any solder mask that might get in the way. Be careful not to snag or stretch the lifted conductor while cleaning. They are very fragile and can easily break. After you have scraped back any obstructions, be sure to remove the loose material and clean the area thoroughly. Now, in order to rebond the conductor to the board, we'll mix 2-part liquid epoxy in a small plastic cup or flat clean surface. Gently press the lifted circuit down into contact with the base material. The next step is called an overbond. We'll apply an additional epoxy layer all along the surface of the lifted portion of the conductor. Spread this layer out across the top of the lifted portion, down the sides, and overlap slightly onto the board. Take care not to get any epoxy on the surface of nearby lands. When you're finished, cure the epoxy as per manufacturer's instructions. Now we'll evaluate this repair. Make sure that a solid bond has been accomplished. The first subject we'll be discussing in this section is the use of 2 very different types of conductor replacement material. Conductor replacement material without adhesive and adhesive-backed conductor replacement material. Replacement material without adhesive may come in a frame or in long strips or rolls. This non-adhesive backed replacement material is known by different names throughout the industry and is sometimes called foil jumper, circuit track, tracing, and etch, to name a few. For the purposes of this program, we'll refer to all non-adhesive backed conductor replacement material as foil jumper conductor replacement. In this program, all conductor replacement material that is adhesive backed will be called adhesive backed conductor replacement. Deciding which one to use depends on the nature of the damage. A note of caution must be mentioned at this point. Every time a damaged or missing conductor is replaced, the replacement must have the same conductive properties as the original. In other words, you must select replacement material that is the same thickness and width as the original conductor. A replacement can never be smaller or thinner than the original because it could burn up when electrical current is supplied. The replacement conductor can be just a little bit larger than the original as long as minimum spacing requirements are maintained. Always check with the supervisor if you can't match the original exactly. Foil jumper material will probably be your best choice for 3 types of conductor replacement situations. The first involves replacing a long straight run of missing conductor. A long straight run means that the missing conductor that you are replacing runs along in a straight line and is longer than adhesive-backed replacement material available in a frame. The second type of conductor